2 weeks ago, the forecast for the start of summer was quiet. As of yesterday morning, it is one of the most loaded flood configurations meteorologists have named on the continent in years, and it lasts through the opening 4 days of June. 2 oceans are feeding it. The ground in the southeast is already saturated. The first wave hits this weekend, and the second wave hits ground that has not had a chance to dry. This is the video that explains what shifted, why it matters, and what comes next. Yesterday morning, 5 regional offices of the National Weather Service and the National Weather Prediction Center named the same atmospheric configuration in their morning discussions. Chicago, Philadelphia, Los Angeles, Boston, New York, plus the National Center in College Park, Maryland. Each office, working independently in its own area, forecast discussion, used the same language. They called the configuration an omega block. They used the phrase slow moving. The Weather Prediction Center put it in its national discussion in plain operational terms. An amplified upper-level synoptic pattern will remain in place into early next week before turning more zonal mid to late week. The general pattern features troughing over both the west and east with ridging in between. This convergence of language across 6 independent forecast offices is itself a signal. Operational forecasters do not invoke blocking patterns by name unless the configuration is unmistakable. The fact that 5 regional offices and 1 national center all name the same shape on the same morning in nearly identical terms tells you the pattern is locked in. The shape is shaped like the Greek capital letter omega, a central ridge of high pressure bulging upward through the central United States and Canada. A closed upper-level low parked over central California to the west. A second closed upper-level low parked over southeastern Canada and New England to the east. The whole structure spans the continent. What makes this configuration the story today, on Friday, May 29th, 2026, is what it is forecast to do over the next 10 days. And what it is forecast to do is shift the June 2026 flood outlook in a direction that no one was projecting 2 weeks ago. An omega block is a stalled wave in the upper atmosphere. Under normal conditions, the polar jet stream drives weather systems across the United States from west to east at a steady clip. 3 to 5 days for a front to cross the country. Storms form along the jet, move with it, deposit their loads, and dissipate as the supporting conditions move on. The continent flushes itself out. A block interrupts that flow. The waves in the jet grow larger. Their phase speed slows. The configuration locks in place. While the block holds, the surface weather underneath each part of the structure does not translate. The trough on the western leg holds California and the northern Rockies under cool, unstable precipitation favoring conditions. The ridge over the central United States and Canada produces sustained heat and clear sky. The trough on the eastern leg holds the northeast under cool, cloudy, wet conditions. The Weather Prediction Center is forecasting this configuration to hold through approximately Wednesday or Thursday, June 3rd or 4th, before slowly de-amplifying. That timing places the entire opening 4 days of meteorological summer underneath the same atmospheric configuration that has defined the final week of May. The block is not just a late May feature, it is the opening configuration of June. This Sunday, May 31st, the closed upper low on the western leg of the omega is forecast to arrive over the northern Rockies and spin in place for 48 to 72 hours. The Weather Prediction Center has issued a Day 4 marginal risk for excessive rainfall, covering a large portion of Montana and part of northern Wyoming. The risk continues into Monday, with intensity beginning to wane Tuesday. The mechanism is straightforward. A stationary upper low draws air upward through its center. The air rises, expands, cools, and the moisture condenses out as precipitation. Because the low is not moving, the precipitation falls on the same geographic footprint for 2 to 3 consecutive days. Layered on top of orographic lift from the northern Rockies terrain, the precipitation concentrates over a narrow band of basins. The basins drained by the Upper Missouri, the Yellowstone, the Bighorn, the Powder, the Tongue, and the Musselshell rivers are all in the geographic footprint. Heavy rain is forecast for the valleys. Snow is forecast for the higher elevations of the northern Rockies above approximately 7 to 8,000 feet. Snow at that elevation in late May happens in roughly 1 in 5 years during the May 28th to June 2nd calendar window. The current forecast places this event in the upper tail of that distribution. Downstream, the runoff response will translate through the river systems over the following several days. The Missouri-Yellowstone confluence near Sidney, Montana, will see sustained elevated flow that propagates downstream through North Dakota and into the lower Missouri Basin through the first half of June. Communities along the upper Yellowstone, Billings, Glendive, and along the Bighorn and Powder Basins should treat the next 72 hours as a sustained elevated risk window. Across the southern United States, the ground is already wet. As of yesterday morning, the National Weather Service had 30 flood warnings in force across the southeast, the Gulf Coast, the Ohio Valley, and West Virginia from antecedent rainfall. 2 flash flood warnings were active in eastern Tennessee, Cocke and Greene counties, with 2 to 5 inches of rain reported. Multiple river flood warnings remained in effect along the Pearl, the Pascagoula, the Tombigbee, the Leaf, the Chickasawhay, the Wolf, the Calcasieu, the Aransas, the Nueces, the Tres Palacios, the Copano, the San Bernard, the Driftwood, the West Fork, the East Fork White, and the South Fork Licking. The atmosphere about to release the second moisture pulse is not falling on dry ground. It is falling on basins that are already at or near field capacity. The runoff coefficient, the fraction of rainfall that reaches the river system, rises from roughly 0.1 to 0.2 on dry ground up to 0.7 or 0.8 on saturated ground. The same precipitation event produces 3 to 4 times the streamflow response on saturated ground. The Weather Prediction Center has issued Day 4 and Day 5 marginal risks for excessive rainfall covering parts of the southeast into Florida. The Miami Forecast Office identified the moisture transport mechanism, a channel of tropical moisture advection from the western Caribbean into the eastern Gulf and across the state of Florida. The Miami office specifies forecast precipitable water in the top 10th percentile for the calendar date, meaning the atmospheric water column over Florida this weekend will be among the wettest 10% of all values ever observed over the location in late May. Top decile precipitable water increases the conditional probability of 3 inch per hour or greater rainfall rates in convective storms by approximately 30 to 40%. A wavy frontal boundary will drape across the southeast starting Sunday and slowly nudge southward through the weekend. Cells will form along the bends in the boundary. The bends will not move. The same cells will form in the same places, hour after hour. This is the operational definition of training storms. Training storms over saturated ground are the proximate dynamical cause of nearly every catastrophic flash flood event in modern American history. The Birmingham Forecast Office in Alabama identified the configuration in its discussion yesterday. A surface frontal boundary will nudge into the far northern portions of Alabama Friday and slowly nudge southward across the state over the weekend, producing better rain chances Friday through Monday with the focus of the frontal boundary. The Houston-Galveston office is forecasting daily chances for showers and storms from Sunday through at least midweek as several impulses undercut the mid and upper level ridge. The Miami office is forecasting the highest isolated flooding risk today and continuing through the weekend as the southerly low-level flow and more westerly flow aloft produce training or slow-moving storms when the sea breezes collide and drift eastward. Every regional office along the Gulf Coast and Southeast is converging on the same forecast: sustained, daily rainfall on saturated ground for the duration of the configuration. The configuration is operationally distinctive because both ocean basins are connected to the same continental airspace. On the western flank, the closed upper low over central California is drawing moisture northward from the eastern Pacific. The National Hurricane Center yesterday flagged a broad area of low pressure forecast to develop early next week well southwest of the Baja California Peninsula. The Eastern Pacific Outlook states that some gradual development of the system is possible. On the eastern flank, the eastern leg of the Omega is channeling moisture from the western Caribbean and the sustained warm North Atlantic into the eastern Gulf and Florida. The Atlantic outlook from the National Hurricane Center yesterday: tropical cyclone formation is not expected during the next 7 days. The moisture is real. The organization is not. There is no tropical cyclone forecast for the Atlantic. There is enormous available moisture being transported by the Omega circulation, and the southeast flood forecast is dependent on the moisture, not on cyclogenesis. Where do the two streams converge? Inside the block. The Pacific moisture converges over the northern Rockies on Sunday and Monday as the western upper low spins up. The Caribbean moisture converges over the southeast through next week as the frontal boundary holds in place and the second pulse arrives. Same configuration. Two moisture sources, two flood pulses, one continental block holding everything in place. The configuration is operationally rare because the two moisture feed setup amplifies the total moisture load available to the flanks of the block beyond what either basin could supply alone. Underneath the central ridge of the Omega, the surface signature is the opposite of the surface signature on the flanks. Bismarck, North Dakota reached 92 degrees Fahrenheit yesterday. Bismarck's climatological first 90-degree day of the year is June 7th. The pattern is running 10 days ahead of schedule. A heat advisory was in force across portions of central Montana yesterday for feels-like temperatures of 101 degrees Fahrenheit. In May, at northern plains latitudes, the combination of mid-90-degree air temperatures and elevated moisture being lifted into the ridge by the same Omega circulation is producing feels-like values that are operationally indistinguishable from peak August conditions in the Deep South. 6 red flag warnings were active under the ridge yesterday. North Dakota in the 7 westernmost counties, Utah in the Henry Mountains and Grand Staircase fire weather zones with relative humidity 8 to 10%. Arizona in the Little Colorado River Valley and Painted Desert with relative humidity 7 to 14%. Colorado in the North Fork zone, plus an expansion zone in southeastern Utah. 2 additional fire weather watches were issued for today across Colorado. Fire Weather Zone 292 and Utah Fire Weather Zone 491. 1 configuration, 4 simultaneous hazards: heavy rain and mountain snow over the northern Rockies. Critical fire weather across 6 states under the ridge. Heat dome conditions across the northern plains. Persistent flooding storms across the southeast. Same wave, same block. Different geographic accident of where the legs and the ridge anchored. The reason this matters operationally is that the phrase slow moving carries a specific consequence in the forecast literature. The arithmetic of rainfall is simple. The total at any single point equals the rainfall rate multiplied by the duration. If a weather system moves at normal speed across the country at 20 to 30 miles per hour, a 50-mile wide storm complex passes over any single point in about 2 hours. If the steering flow stalls, the same complex sits over the same point for 4 hours, 6 hours, 12 hours. The rainfall rate may not change. The duration multiplies. The total multiplies with it. Every catastrophic American flood event of the past 50 years that was not directly caused by hurricane landfall winds had a stalled steering pattern as the proximate dynamical cause. Hurricane Harvey stalled over southeast Texas for 4 days in August 2017. 51.88 inches of rain fell at Nederland, Texas, the all-time United States single-storm rainfall record. The storm did not have unusual moisture content for a tropical cyclone. What it had was duration. The steering flow had collapsed. The system did not move. The West Virginia floods of June 2016 happened when cells trained over the same Appalachian counties for 6 hours. 8 to 10 inches of rain fell on the same basins. 23 people died. The proximate cause was not extreme moisture. The proximate cause was that the storms formed in the same place over and over because the flow above them had stopped. The Tennessee floods of May 2010 produced 13.57 inches of rain on Nashville in 36 hours. A stationary frontal boundary drove the rainfall. Cells trained along the boundary. The Cumberland River rose to 47 feet above flood stage. 26 people died. The proximate dynamical cause was the same. The frontal boundary did not move. Every single one of these events shares the same signature. The system stalled. The moisture did not stop falling on the same square mile. The basin underneath could not handle what was being deposited. The Big Thompson Canyon flood of July 1976. 144 people killed when a slow-moving thunderstorm complex stalled over a narrow Colorado canyon for 4 hours. The Pennsylvania flood of 1972, when the remnants of Hurricane Agnes stalled over the Susquehanna Basin for 5 days and killed 218 people. The Mid-Atlantic flood of 1955, when Hurricane Diane stalled over Connecticut on top of ground that Hurricane Connie had already saturated the week before. Different storms, different decades, same dynamical signature. The system did not move, and the basin underneath could not absorb what was being deposited. This is the mechanism the Weather Prediction Center is forecasting will produce the Sunday rainfall over the northern Rockies and the southeast, worsening through next week. The block is the steering pattern. The block is what is not moving. The storms that form along its flanks will inherit the stalled steering. They will train. The duration will multiply. The arithmetic is brutal. The dispute in the peer-reviewed literature is not whether blocks are happening more often. It is over the magnitude of the trend. The mechanism itself is settled. The polar jet stream is driven by the temperature gradient between cold polar air and warm tropical air. When the gradient is strong, the jet runs fast and stays relatively zonal. When the gradient weakens, the jet slows, the waves grow larger, and the waves can stall. Rantanen and colleagues, publishing in 2022 in Communications, Earth, and Environment, documented that the Arctic has warmed approximately 4 times faster than the global average since 1979. 4 times faster. That warming compresses the meridional temperature gradient. The gradient drives the jet. A weaker gradient produces a slower jet. A slower jet produces larger waves more prone to blocking. Hahn and colleagues, publishing in 2021 in Water Resources Research, examined what they called low-phase speed Rossby wave packets, the mathematical descriptor of slow-moving large-amplitude waves. They demonstrated that those packets cluster preferentially in certain geographic positions and certain seasonal windows. The packets are not random. They are the proximate driver of persistent regional drought on dry sides and persistent regional precipitation on wet sides. The current omega block is, in the language of the academic literature, a low-phase speed wave packet. The forecast precipitation it is producing on the wet sides, the northern Rockies and the southeast, is the operational expression of the Hahn mechanism. Kornhuber and colleagues, publishing in 2020 in Nature Climate Change, demonstrated that quasi-resonant amplification of wave number 5 and wave number 7 patterns produces up to 20 times the concurrent extreme weather probability across distant regions of the same hemisphere. This is part of why the current block is simultaneously producing heat in the northern plains, fire weather across the desert southwest, and forecast flooding in 2 non-contiguous regions. The pattern is not localized, it is hemispheric. Morales and colleagues, publishing in 2019 in the Proceedings of the National Academy of Sciences, demonstrated that saturated soils amplify the precipitation to flood translation through the runoff coefficient mechanism described earlier in this video. Saturated soils have no remaining storage capacity. The runoff coefficient rises from roughly 0.1 in dry conditions to 0.7 or higher in saturated conditions. This is the amplification factor operating across the southeast right now. The block is the cause. The training storms are the immediate process. The saturated ground is the multiplier. The flood is the outcome. Through Saturday, the western upper low closes off. Model run-to-run consistency on rainfall placement will increase. By Saturday afternoon, high-resolution short-range models will provide concrete quantitative precipitation forecasts for the Sunday event. Emergency managers in Montana and northern Wyoming will be staging based on those products. Sunday afternoon and evening is when the peak rainfall is forecast. Watch the Weather Prediction Center Day 1 outlook issued Sunday morning for potential upgrade from marginal to slight risk if the model consensus tightens around the heaviest band. Monitor the Upper Missouri, the Yellowstone, the Bighorn, and the Powder River gauges through Sunday night and into Monday for the first signal of runoff response. The Missouri Basin River Forecast Center will issue updated stage projections as the event unfolds. Across the southeast, monitor the Weather Prediction Center Day 1 outlook Saturday and Sunday morning for marginal risk areas. Track regional flash flood guidance from the relevant National Weather Service offices in Birmingham, Mobile, Tallahassee, and Miami. Watch for training storm signatures in the radar mosaic over central and southern Florida, where the sea breeze convergence combined with the southerly low-level flow is the most likely flash flood setup. The active river flood warnings already in place across the Pearl, the Pascagoula, the Tombigbee, and the Calcasieu will be the leading indicators of compound response. If those stages climb further before the second pulse arrives, the basin response to the second pulse will be amplified accordingly. The block is forecast to hold through approximately Wednesday or Thursday, June 3rd or 4th, before slowly de-amplifying. That timing places the first 96 hours of meteorological summer underneath the same atmospheric configuration. The southeast flood pulse is forecast to worsen later next week as the trapped Caribbean moisture cycles back south and east when the block releases. The second pulse hits ground that has not had a meaningful drying interval since the first pulse this weekend. The forecast skill on a 7 to 10 day window with a confirmed continental block is operationally robust. The unknowns are which specific basins downstream of the marginal risk areas reach flood stage, and when and how much of the runoff from this weekend's pulse is still translating downstream when the second pulse hits next week. This is what shifted yesterday. 2 weeks ago, the operational outlook for the first week of meteorological summer was a relatively quiet zonal pattern. As of yesterday morning, the operational outlook is a continental flood configuration with both ocean basins feeding moisture into the same continental airspace and a stalled steering pattern holding everything in place through the opening 4 days of summer. The block is the configuration. The flood is the consequence. The release is somewhere in the first week of June. And the runoff translation through the river systems will continue propagating downstream for days and weeks after the configuration itself releases. We will be tracking this as it develops.